A very good morning and welcome back. So, as we were discussing about a few examples on how you can utilize Laplace transform or impedance transform method in order to solve time-dependent circuit, in the same series, we would take two more examples with different flavors. The first example is like this. So you can just draw the diagram and write initial conditions. There's a switch and a resistance. No active independent source is given. The switch was thrown at t equals to 0, let's say. The value of inductances are given as 3 henries, 6 henries, and this one is 6 ohms. Okay. So what is given is that the initial conditions which you will consider, for example, let us say I1 is the current that flows through 3 Henry inductor and I2 is the current which flows through the 2 Henry inductor. Then it is given that I1 0 minus is equals to 1 amperes and I2 0 minus is equals to 2 amperes. The initial conditions are given as 1 ampere and 2 ampere, and the switch is closed at t equals to 0. What they're asking is that find out what will be the value of I1 for all t's and I2 for all t's. So initial values of currents are given. You have to find out the value of current I1 and current I2 for all t's. Definitely the t has to be greater than 0 in this case. Fine. So we will try to solve this particular circuit or whatever given in this example through Laplace impedance transform method. You know that if you are given an inductance of 3 henries, let's say, so you have to convert this in S domain, and for doing so, what you need is you just need to convert it into this form that you have an inductance. Let's say if its key value is S, then the value of this particular thing will be Ls. So I can write that this is equals to going to be 3S in ohms. And if the current is flowing like this, which was I1, so you consider that this was I1, but the current will now divide in a branch, and the source which you are now drawing should be equals to I1 0 plus by S. Okay. With a similar argument, you can also write for a 6 Henry inductance that the S domain equivalent of this particular inductance would be 6S and a current source with I2 plus or I2 0 plus by S. Okay. Rest would be same. So in a way, what we have done is, in order to convert this particular circuit in S domain, replace this inductance, and this resistance with their equivalent S transforms. So doing so, what we will get is this. A 3 Henry inductance with a current source like this. You have a 6 Henry inductance with a current source like this. I would be writing the values, don't worry. And you have an impedance of value 6 ohms. That's it. The switch can now go, that can be removed because we have now taken account the effect of that switch. Okay, we have taken in account the switch of that particular switch. So you just write the values that this is of 3S ohms, this is 6S. The value of this particular current source should be I1 0 plus by S. And what was the initial condition? I1 0 minus. For inductances, you know that I1 0 minus has to be equals to I1 0 plus. This is what is the requirement for initial conditions from inductor. Similarly, you can have I2 0 minus has to be equals to I2 0 plus. and which should be equals to 2. Okay, so we got these values at least, and you can put in that this has to be equals to I0 plus by S. So you can write it as 1 by S amperes, and this has to be equals to, this current source is 2 by S amperes, and you know that the impedance remains same, 6 ohms. This is 3S ohms, 1 by 6, 1 by S amperes, 6S ohms, 2 by S amperes, and that's it. Okay. And now what you have to do is you have to solve it for, let's say, ये हो गया आपका I1 and this one is your I2, and you have to solve for I1 and I2. Okay, you have to solve for I1 and I2 like this. At this point, I can consider that, let's say, some amount of current is coming over here, and it is then divided into two branches. So the current which will flow through this 6 ohm impedance should be equals to I1 plus I2. Don't worry about it. But looking at the things which are available, what we can simply do is we can apply either KVL with mesh analysis, although you would say that why should be applying mesh analysis because the currents are already given. So that is fine. You need not worry about it. The only thing which you should see is that the voltage across all the three, like this particular thing, and this particular thing should be same. And we can utilize the fact that the voltage across this 3S ohm impedance would be I1 minus 1 by S times 3S. Okay, so like that, you can apply voltage analysis as well, and you can go by mesh analysis and node analysis too. So when you would apply node analysis, remember that you will then have to convert all these into admittances, which are right now in impedances. So you have to convert those into admittances, and what this is. So what I'm saying is that the voltage which you would see across this particular impedance is going to be equals to I1 minus 1 by S times 3S ohms. And this should be equals to, the voltage across this, which is I2 minus 2 by S into 6S ohms. Okay. And this indeed should be equals to, this particular thing should be equals to minus of I1 plus I2 into 6 ohms. Why minus? Because I'm taking this to be a passive element. So for passive element, the voltage and the direction of current should be from plus to minus, not minus to plus. That's why, because of like taking in consideration the conventions, I should take a negative sign over here. Done? So you can solve it either ways. You can utilize that I now have got two equations. One is that I1 minus 1 by S into 3S is equals to I2 minus 2 by S into 6S. This is, let's say, your equation 1. And another equation, you can say that, let's say, I2 minus 2 by S into 6S is equals to I1 plus I2 with a negative sign into 6 ohms. Okay. And then what you would have to do is you would have to solve for I1 and I2. So you have two equations, equation 1 and equation 2. And using these two equations, you have to solve for I1 and I2. You can take I2 one side, I1 another side, and then you just have to solve for it. And when you would solve it, this I can leave as a small homework for you. You will get I1 coming out to be S minus 3 upon S plus 3, and I2 coming out to be 2S plus 3 upon S plus 3. Okay. So you have now got I1 in S and I2 in S, and you just have to now convert it into, like, using inverse Laplace transform, what is going to be I1 of t and what is going to be I2 of t. That's it. So the step from which you would solve for I1 and I2 using these two equations, and you would reach this point that I1 is equals to this particular thing, I2 is equals to this particular thing. Okay, so let me just take I2 of S as far as I see, it is equals to 2S plus 3 upon S plus 3. As I earlier told you that you can convert it into A upon S plus B upon S plus 3. Solving that, you can find out that actually A into S plus 3 plus B into S has to be equals to 2S plus 3 by taking LCM both side. Now taking B, S is equals to 0, let's say. So if I take S equals to 0, I would get 3A is equals to 3. It means A is equals to 1. Similarly, you can solve for B by taking S equals to minus 3. So the moment you would take S equals to minus 3, this would become minus 6. Minus 6 plus 3 is minus 3, but you have taken a minus 3 over here as well. So your B will be equals to positive 1. So your A equals 1 and your B equals 1 as well. So when you will be solving for that, you can simply say that your I2 of S is equals to 1 by S plus 1 by S plus 3. Okay. You can take it like 1 by S plus 1 by S plus 3. Let me just check it whether it is fine or not. Let me just check it whether B would be plus 1 or not again. So we are putting S equals minus 3. So it would become minus of 3B is equals to minus 6 plus 3 is minus 3. So B equals plus 1. Putting S equals 0, you would get 3 by 3, which is fine. Yeah. So we are on right track. We got it right. So it would be S plus 3 plus S is 2S plus 3. Fine. So your I2 in terms of S is this. You can just take Laplace inverse of I2 of S. So it is something like when you are having 1 by S. So Laplace transform of 1 is 1 by S. So you get UT because you know that this is something like shifting on. Uh, this is just Laplace inverse of 1 is 1 by S. That's it. Okay. So I can write that it is going to be equals to 1 plus Laplace transform of 1 upon S plus 3. So it is something like taking 1 e to the power minus 3 of t. E to the power minus at is equals to your ut. So we have got that it should be equals to 1 plus e to the power minus 3t ut. And this is the value of your I2 for all t's. Okay. So this is ut. This is ut. So 1 plus e to the power minus 3t ut is your value of I2t. Now, what is going to be the value for I1t? So for I1, as I told you, we calculated I1 of S is equals to S minus 3 upon S plus 3. That's it. So by the similar argument that you can take it as A upon S plus B upon S plus 3, which is equals to S minus 3 upon S plus 3. Using that, I can write that S minus 3 has to be equals to A S plus 3 plus BS, taking S equals to 0. So this is what we are going to get. Putting S equals 0, we will get the value of A. Putting 0, we get minus 3 is equals to 3A, which implies that A has to be equals to minus 1. Similarly, if we put S equals to minus 3, you will get minus 6 is equals to minus 3S. So you will get S is equals, B is equals to 2. So I should say that minus 3B, and it would give you that B equals to 2. So you get your value of A equals to minus 1, B equals to 2. And when you would do it, you solve it further, you will get that I1S is equals to minus 1 upon S plus 2 upon S plus 3. So taking the Laplace inverse of this particular thing, the Laplace inverse of I1 of S, you would get minus of Laplace inverse of 1 by S is 1 plus twice Laplace inverse of S plus 3 is e to the power minus 3t. And then definitely, because everything happens after t equals to 0 or 0 plus, we can say that minus 1 minus 2 e to the power minus 3t ut is the value of I1t. So you have actually solved for I2t as well as I1t using the following technique. Fine. In similar way, you can take another example where you might have to apply the concept of node analysis in solving the voltages across the given circuit. Okay. So let us take another example. And it is given that you have a capacitance you have a current source, and you have an inductance. Sorry, you have an inductance. So this is an inductance. And over here, let's take a resistance. So the value of the current source is 5 by S amperes. The value of impedance across the capacitance is, let's say, S mhos. It is given. It is already given. The value of admittance is 1 mhos. The value of inductance is 1 by S mhos. And what they're asking is find out the voltage across the capacitance and across the inductance. So you have to find out V first and V second. Okay. So what you can do is you can apply node analysis and solve for V first and V second. So you know that this can act as node first, this can act as node second, and this we can take as node third or as reference. Okay. So when you want to apply node analysis, let's say you want to apply it for first node. Okay. So at node 1, you first take the sum of admittances, which is S plus 1. So you have S plus 1, V first, I can say, V first, minus common between first and second is 1, V second, is equals to the current coming in node first is 5 by S. Okay, so what I've done is I've applied node analysis. Similarly, for the second node, I can write what is the sum. Sum is 1 by S plus 1. So I can write that plus 1 plus 1 by S V second. With a negative sign, what is common between second and 1? 1 V first equals to 0. Okay. And when you would solve it for V1 and V2 using these two equations, you have to do what? You have to solve for V first and V second. Okay. So what you have to do, like you know the way, take the coefficient V1 is S plus 1 over here, it is 1 only. Take multiply by S plus 1 in the second term, and then you can just add the two, and that's it. You're done with it. So while you will be solving it, after solving, I'm still skipping this step so that you, while making your notes, have a good practice of how to solve such equations. You can simply say that your V first should be equals to 5 times S plus 1 upon S square plus S plus 1, and you have to verify it. And V second should be equals to 5 upon S square plus S plus 1. Okay, so this is what we are saying as V first and V second. Now it can also be asked that you have to solve it for not just V first and V second, but in time domain what it would be. So you have solved it for S domain only. What would be the value of V1t and V2t in time domain? And that I'm giving you as a DHA. Okay, so this becomes your DHA number 6. You have to complete this equation, solve everything. In our next class, we will pick up a more generalized way of solving differential equations, which we call as state equation technique. But that is a thing which I'm going to reserve for the next class. Thank you so much, all of you.